We're going to introduce polynomials today. Okay, that's polynomials. You will notice that I have actually typed out a bunch of the definitions since we are in a different format right now with the online learning. I didn't want you to have to take a lot of time to write some stuff down. If you want to get paper out and take any notes you wish to, feel free to do that. If you want to print out the blank notes that I have attached, you can do that. But I just filled some of this in to make this a little easier. This first introduction to polynomials is going to involve a bunch of definitions. So I'm going to be throwing a bunch of definitions out at you. They're written down on that PDF I attached. They're here. You can go back and use them throughout all your practice and anything we do this week and next week with polynomials. Okay? So poly, as you are probably aware, means many, and nomials means name. So literally it means many names. That doesn't really make a whole lot of sense when you see what it is, but that's what the breakdown of the word is. Now, a monomial. Mono means one. So this is one of the things we're talking about. And here's the definition. A constant, a variable, or the product. This is important. The product of constants and variables. So 7 is a constant, so it's a monomial. X squared, that's a variable. That's a monomial. And here I have 1/2 x squared y z to the 4th. That is a product of constants and variables. So that is a monomial. That is a single thing. Okay, we're going to call that a term in a minute. That's a single thing. There are some things that it cannot have. You cannot have variables with fractional or negative exponents, and you can't divide by a variable. So 2x to the negative 2y is not a monomial because of that negative exponent. 3 over x is not a monomial because you're dividing by a variable. If you'll remember, negative exponents and dividing by the variable, that's the same thing, right? So this and this mean the same thing. 4x to the 1/3. We have not talked about fractional exponents. Fractional exponents have to do with roots. So this would be like the cube root of x. That's not allowed for it to be a monomial. And then here, negative 3 times the square root of x, that would be x to the 1/2. So that's a fractional exponent. That's not allowed, okay? So it can't look like any of these things. Now, a polynomial, poly means many. It's the sum or difference of one or more monomials. So it is monomials all connected by pluses and minuses. So 3x squared y, that's a monomial, plus 2xy cubed, that's a monomial, minus 5y, that's a monomial, plus 7, that's a monomial. So a bunch of monomials divided by pluses and minuses. And each of those is called a term. So this polynomial has 1, 2, 3, 4 terms. So 3 special names. These are the only ones that have special name. A monomial, we've already talked about, has 1 term, a single term. A binomial, bi means 2, has 1, 2 terms. And a trinomial, tri means 3, has 1, 2, 3 terms. After that, they don't have a special name. If it has 4 terms, we would just say a polynomial with 4 terms, or a polynomial with 7 terms. All right, the next thing that has to do with vocabulary, and is also something we can look at and find of a variable or of a polynomial, is its degree, okay? So the degree of a variable is its exponent. That's important, okay? It has to do with the exponent. So this right here, x to the 5th, has degree 5 because the exponent is 5, okay? X, remember, it just has a 1 up there. So this one has degree 1. And the degree of a constant is 0. If it's just a constant, it has degree 0. And the reason for that is because really we could say there's an x to the 0 there, right? What is anything to the 0 power? 1. So that's 3 times 1. So if it's just a constant, it has degree 0. Okay? Next, the degree of a monomial is the sum of the degrees of its variables. So this monomial right here, negative 2a squared b cubed, you look at the variables and you say, well, that has degree 2 and that has degree 3. So 2 plus 3, this has degree 5. So that monomial has degree 5. This one right here, notice we don't care about the constants. We're just looking at the variables because the constants have degree 0, right? So this has degree 5, the y has degree 1, and the z has degree 7. So 5 plus 1 is 6, plus 7, that has degree 13. So if you're looking up at a monomial to find its degree, you add up all the exponents. Then finally, when you're looking at a big old scary polynomial, this is a monomial and a monomial and a monomial, you find all three and you take the highest degrees, okay? So this first term has a 1 and a 1 and a 1, right? Because x to the first, y to the first, z to the first. So it has degree 3. This second one has degree 2 plus 1 plus 3. So 2 plus 1 is 3, 3 plus 3 is 6. And then this last one has degree 3 plus 2 plus 4. 5 plus 4 is 9. So you look at those, you take the highest, and this polynomial has degree 9. So basically what you do, if it's just an exponent, if it's just a variable, you take the exponent. If it's a monomial, you add the exponents. And if it's a polynomial, you have to add the exponents for each term, and then you take the highest one. All right, so the terms and the degree is probably the most confusing thing of what we're going to do today, and you're going to get to do some practice with that in a minute. The next thing we're going to do is where we add polynomials. This is not too bad, because when you add polynomials, what you're doing is you are combining like terms. So this goes all the way back to something you learned in the 7th grade. 7x plus 3x, we get 10x, right? Everybody knows how to combine those. 4x squared plus 2x squared is 6x squared. Very, very important to note that when you combine like terms, the exponent does not change. That's important. If you start changing that exponent when you're adding, you're going to miss a lot of things, okay? So here's what we do. I see the sum of two polynomials. I have parentheses here, 4x squared minus 9x plus 1, and I'm adding to that x squared minus 5x minus 3. Those parentheses don't really need to be there because there's nothing outside of them. So all I'm going to do is look for my like terms. So 4x squared plus x squared, that's a 1x squared. That's going to be 5x squared. Then I've got minus 9x minus 5x. That's minus not 13. That's minus 14x. And then plus 1 minus 3 is minus 2. So when I add those two polynomials, I get 5x squared minus 14x minus 2. Sometimes they write the polynomials so that the like terms are already lined up, and that's kind of handy. So 3a squared plus 6a minus 2 plus 2a squared minus 8a minus 7. This is just combining like terms. 3a squared plus 2a squared is 5a squared. Positive 6a minus 8a is minus 2a, watch your signs, and negative 2 minus 7 is negative 9. Okay, so that's how you add. You look for the like terms, you combine them, don't forget your sign rules, and that's all there is to it. Okay, subtraction. Subtraction is very similar. As with most things involving minus signs, it can cause issues, so you have to be careful when you're subtracting. Subtracting, just like any other time we've subtracted, it means to add the opposite. So here's your rule. Here's what you do. You change the signs of the second polynomial and you add, okay? So 3x squared minus 2k plus 5. There's nothing outside those parentheses, so I'm just going to copy the first polynomial. And then this minus, remember a minus outside of parentheses changes all those signs, right? We haven't done that in a while, but that's what we're doing. So we're going to go minus 2k squared plus 5k minus 1. So I changed all the signs of the second polynomial. Now I'm adding. Now I'm looking for like terms. So 3k squared minus 2k squared is 1k squared. Minus 2k plus 5k is plus 3k. And then 5 minus 1 is a positive 4. So my final answer is k squared plus 3k. I think I tried to do an x there, didn't I? Plus 3k plus 4. Okay? Now, this next one, they're stacked. I'm not real crazy about them stacked with subtraction, but sometimes that's the way it is. So my top one I just leave alone. W squared minus 10w plus 2. The bottom one, I change the sign of everything in the bottom. So minus 4w squared minus w minus 2. And now I'm going to add these two. So w squared minus 4w squared is negative 3w squared. Negative 10w plus a negative w is negative 11w. And then 2 minus 2 is 0. That goes away so I don't have to write it. Okay? All right, so what I want you to do, I have attached a page with a few practice problems, some of the classifying polynomials, some about the degree, some of adding and subtracting. Try those problems. Those are the ones we're going to go over in our Zoom session. See you then.